In this lesson, we'll take a look at another variation on games, two-dimensional games that combine ordering and grouping. Here's the setup. Of the 5 Pole children, Sarah, Theo, Uma, Will, and Zoe, 3 are left-handed and 2 are right-handed. Each of the 5 children was born in a different one of 7 calendar years, 1990 through 1996. The following conditions apply. What's going to be the core of this diagram? Well, there's order involved, defined by the calendar years in which the children are born, but there's grouping involved here too. Each child is either right or left-handed, so you'll have a group of 2 elements assigned to each year in which a child is born. So, first draw a basic order diagram for the years from 1990 to 1996. And now is a good time to recognize that you have 5 children and 7 years, and all of the children are born in different years. That means you'll have 2 empty spaces in the chart. Add 2 X's to your list to keep track of the 2 years in which no child is born. Now there's still the handedness to account for. First, add another list to your inventory, 3 L's and 2 R's. Add a second level or row to the diagram. This allows you to keep track of the grouping aspect of the game. That is, for each year in which a child is born, you will have 2 elements assigned, the name of the child and the handedness of that child. Now that you have the diagram in inventory, it's time to symbolize the clues. The first clue is that no 2 left-handed children were born in consecutive years. This is a standard anti-block. You can't have 2 L's in a row. The second clue tells you that no 2 right-handed children were born in consecutive years. So that gives you an RR anti-block. Next, Sarah, who is left-handed, was born before Uma. This is 2 pieces of information in 1 clue. First, create a block corresponding to how it will look in the chart to show the SL group. Then add on the range aspect. This block has to come sometime before U. The fourth clue, that Zoe was born before both Theo and Will, is a branching range. Give yourself a Z on the left with 2 separate dashes showing that both T and W are somewhere to the right. According to the 5th clue, a left-handed child was born in 1991. This is the best of all types of clues, a placement. Write it down and then put it directly into the chart. The final clue tells you that Uma, who is right-handed, was born in 1993. Another excellent clue. Write it down and then place U and one of your R's in 93. Remember that once you have all of the clues symbolized, you must double-check carefully before moving on to the next step. And the next step is to look for deductions. Since a left-handed child was born in 91 and you, who is right-handed, was born in 93, clue number 1 and clue number 2 combined let you know that there can be neither a left-handed nor a right-handed child born in 92. There is also no left-handed child in 90 and no right-handed child in 94. Since 92 is neither left nor right, and every child needs to be either left or right-handed, you can block off all of 92 with one of your 2 X's. Since U shows up in 2 clues, one of which also mentions S, that is a good place to look next. S has to be before U, and you deduce that there's no child in 92. And you also deduce that there cannot be another lefty in 90 without violating the first clue. So the only place S can be is in 91. Clue number 4 lets you know that Z can't be in 95 or 96, since T and W have to come after Z. It also lets you know that neither T nor W can be in 90, since Z has to be before them. Those are all of the basic deductions. If you need to, pause the recording now to catch yourself up. What elements do you have left over? T, W, and Z. Which one of them is the most restricted? Z, because it has to have 2 other elements after it. You already marked that Z can't go in 95 or 96, so how many slots are left that can accommodate Z? Only 2. Z can only be a righty in 90 or a lefty in 94. So there are basically only 2 variations on how the rest of the game can play out. Guess what? That's a deduction too, a major deduction. If you can ascertain that there are only a few basic ways a game can play out, you can diagram them before you attempt the questions. If you diagram those limited variations, then you will know for sure everything that can happen in the entire rest of the game, which would be pretty helpful, don't you think? So let's diagram both Z scenarios. Add a second 2D row just like the first to your diagram. Now, put Z as a right-handed child in the 1990 slot in the first scenario, and as a left-handed child in the 1994 slot in the second scenario. Now think about the remaining elements. What's left? T and W. In the first scenario, if you make Z a right-handed child born in 90, that's it for the two right-handed children. They are Z and U. That means that all of the other kids have to be lefties, so T and W are both lefties. The only way you can distribute two lefties among 94, 95, and 96 is if you separate them by putting one into 94 and the other in 96, since you can't have two lefties next to each other. That eliminates 95 entirely. That leaves only two slots for the two elements, and as far as you know right now, either T or W could be in either slot. Now for the second scenario. Make Z a left-handed child in 94. You already have deductions that tell you that T and W can't be in 90, so you can eliminate that year. That means they'll have to be in 95 and 96. You know one of them will be a lefty and the other will be a righty, since you already have two lefty children and one righty child filled in. There can't be a lefty in 95 because there's already a lefty in 94. That means the righty has to be in 95, which means the remaining lefty must be in 96. You don't know whether T or W is the lefty or the righty, and you don't know which one comes before the other one. So for now, either T or W could be in 95 or 96. This is great. You now know everything that can happen in the game and everything that cannot happen in the game. You'll basically just have to determine whether each question applies to scenario 1, scenario 2, or both scenarios, and proceed from there. Now you're ready to attack the questions. The first question asks, which one of the following could be an accurate matching of each pole child with the year in which that child was born? This looks a lot like a grabber rule, but it only gives you the children, not the handedness. Clue 4 allows you to eliminate B because T is not after Z. Clue 5 knocks A out since it has no child born in 91, and Clue 6 eliminates C because U isn't in 93. After that, you actually have to rely on your deductions in order to decide between D and E. Both answer choices can only be based on scenario 1, since they both have Z in 90. In scenario 1, T and W are 95 and 96, not 94 and 95, so E must be the answer. The second question asks, if Sarah was born before Zoe was born, then which of the following statements cannot be true? This is a specific must-be false question, so you should eliminate answers that could be true. The question stem puts S before Z, so you have to refer to scenario 2 only. Choice A, Will is left-handed, could be true, so eliminate it. Choice B, Zoe is left-handed, must be true in scenario 2, so cross it off. Answer choice C, Theo was born after Will was born, could be true, so it's gone too. But answer choice D, Uma was born after Zoe was born, that must be false. Uma was born in 93 and Zoe in 94 in this scenario. Therefore, D is the credited response. The third question is a general question, so skip it and come back to it later. Question number 4 asks, if Theo was born after Will was born, then how many sequential orderings of the children from firstborn to lastborn are possible? This is a specific could-be-true question that requires you to consider both scenario 1 and scenario 2. First, symbolize the new information. W now must come before T. Next, count up all of the different ways in which this could happen. In the first scenario, T can come after W only if W is in 94 and T is in 96, so there's only one way to arrange the elements in scenario 1 according to the question task. There's also only one possible arrangement in scenario 2 with W 95 and T in 96 that satisfies the question's requirement. Therefore, B, 2, must be the answer. Question 5 asks, if none of the children was born in 1995, then which one of the following statements must be true? This is a specific must be true question, and it can only work with scenario 1, in which no one is assigned to 95. Choice A, Theo was born in 1994, could be false. Theo could be born in 96, so eliminate A. For B, Will was born in 1994, eliminate it. Will could have been born in 1996 instead. As for C, Will was born in 1996, eliminate it for the same reason. Will could be born in 1994. But choice D, Zoe was born in 1990, cannot be false. That must be true in scenario 1. Pick it and move on. Question 6 asks, if Theo is right-handed, then each of the following statements must be false except. This, once you translate the except, is really a could-be-true question. Only scenario 2 allows T to be right-handed if T is in 95 and W is in 96. Choice A, Theo was born in 96, is false in that scenario. Theo has to be born in 95 in order to be a righty. Cross it off and go on to B. Will was born in 1995. That must also be false. Will has to be born in 1996 in this scenario. Cross off B and move on to C. Uma was born exactly 3 years before Theo was born. Yet again, this must be false. Uma in this situation was born exactly 2 years before Theo. Moving on to D. Zoe was born exactly 1 year before Theo was born. Yes, this could be true. In fact, it must be true with Theo in 95 and Z, as always, in 94. That gives you D as the correct answer. On to your last specific question, number 7. If Zoe was born before Uma was born, then which of the following statements must be false? Z could only come before U in scenario 1. This is a specific must be false question, so eliminate answers that could be true in that scenario. Choice A, no child was born in 1992 must be true, so it's out. Choice B, no child was born in 1995 also must be true, and it's gone. Choice C, Theo is left-handed also must be true. Eliminate it. Choice D, however, Zoe is left-handed, is definitively false. Zoe is right-handed in scenario 1. That gives you D as the correct answer. That's it for specific questions, so it's back to question 3, your remaining general question. Question 3 asks, which one of the following must be false? So you will be eliminating answers that could be true in at least one of the two scenarios. Answer choice A, none of the children was born in 1990, nor was a child born in 1992, could be true in scenario 2, so you can eliminate it. Answer choice B, none of the children was born in 1992, nor was a child born in 1995, could be true in scenario 1, so you can eliminate that one too. Answer choice C, none of the children was born in 1994, nor was a child born in 1996, cannot work in either scenario 1 or scenario 2. In both options, a child must be born in both of those years, and there are no other possible scenarios, so C must be false and is therefore the answer. And that's the end of the game. So when a game asks you to combine elements of grouping with ordering, create a second row in your diagram and pay attention to vertical and horizontal rules to make deductions and answer questions. Not every game, or even most games, will reduce down to 2 basic scenarios, but if you deduce that there will be very limited scenarios for any kind of game, it's worth the time up front to work them out. You'll make up that time and effort later as you move through the questions and answers with both speed and accuracy. Welcome to 2D order games, spatial arrangements. By now, you should be familiar with order games and the basic game's approach. In this lesson, you'll apply that approach to a new game task. The game setup says, there are exactly 10 stores and no other buildings on Oak Street. On the north side of the street, from west to east, are stores 1, 3, 5, 7, and 9. On the south side of the street, also from west to east, are stores 2, 4, 6, 8, and 10. The stores on the north side of the street are located across the street from those on the south side, facing each other in pairs as follows: 1 and 2, 3 and 4, 5 and 6, 7 and 8, 9 and 10. Each store is decorated with lights in exactly one of the following colors: green, red, and yellow. The stores have been decorated with lights according to the following conditions. Clearly, this is a different type of game. Instead of asking you to put a list of things into a particular order along a single line, they've given you two sides of a street that have a spatial relationship to each other. So you will draw the street as they described it, with the stores on either side. Unlike order games, you'll need to draw the street out in a new diagram for every specific question, so you'll need to plan your space accordingly. The inventory is R, G, or Y for the colors of lights that decorate the stores. Now, move on to symbolizing the clues. Clue 1. No store is decorated with lights of the same color as those of any store next to it. Since this clue applies to all three elements, you can just put an XX anti-block to remind you that two of the same colored lights can't go next to each other. Clue 2. No store is decorated with lights of the same color as the store directly across from it. This clue is similar to the first clue, but shows the relationship vertically, so draw an XX vertical anti-block. Clue 3. Yellow lights decorate exactly one store on each side of the street. Make a note that yellow equals one side only. You can also add a Y next to your master diagram on each side of the street to remind yourself there's one and only one on each side. Clue 4. Red lights decorate store 4. Write it down and then add R to slot 4 in the diagram. Clue 5. Yellow lights decorate store 5. Write it down and add Y to slot 5. You can also cross off the Y to the side of the north side of the diagram, since that single Y has now been assigned. Double-check the clues and move on to making deductions. Look for what each individual clue tells you, but also for links between different clues, and for links between clues and deductions that you make. Looking at Clue 1, you see that neither store 2 nor store 6 can be red, so mark that. Again with Clue 1, neither 3 nor 7 can be yellow, so mark that one as well. According to Clue 2, store 3 cannot be red, nor can store 6 be yellow. Finally, using Clue 3, store 1 and store 9 cannot be yellow either. Now look at the new deductions. Store 3 can be neither red nor yellow, which leaves only one option, green. This means that store 1 cannot be green from Clue 1, and it also cannot be yellow, so it must be red, so mark it as such. Store 6 can't be yellow, nor can it be red, so it must be green. And if it is green, then store 8 cannot be green, so half of the spaces are solved, and the only store without any restrictions whatsoever is store 10. Now it's time to attack the questions. There isn't a grab a rule question, so start with number 2, the first specific question. If green lights decorate store 7, then each of the following statements could be false except. Could be false except translates as must be true. The next step is to draw a new diagram, bring over the constants, and plug a G into slot 7 according to our question. Next, fill in what you know. If 7 is G, 9 must be R since it can never be Y, and now it can't be G due to Clue 1. And now 10 can't be R because of Clue 2. It's all we know for now, so it's time to go through the answers, eliminating the things that could be false. Choice A is out since store 2 could be yellow instead of green. Choice B is out since store 10 could be yellow, not green. Choice C is also out since store 8 could be yellow rather than red. But choice D must be true. You deduce that store 9 now has to be red. That gives you choice D as the correct answer. Question 4 is the next specific question. If green lights decorate 5 stores on the street, then which of the following statements must be true? So give yourself a new diagram, bring over the constants, and circle must be true in the question stem. Next, symbolize the new information by writing down 5 G's and make new deductions. There are already 2 G's in the chart, leaving 3 more to be placed. None of the G's can be next to or across from each other. That forces one of them into slot 2, and since there can never be green in slot 8, the other 2 G's must go into slots 10 and 7. Store 9 can never be yellow, and now with green in 7, 9 can't be green, so store 9 must be red. Finally, think about clue 3. There must be a yellow light on the south side, and the only slot left is 8. Every slot is defined. Now find an answer choice that matches the diagram, which gives you E. Yellow lights decorate store 8. That's it for the specific question, so it's time for the general questions, starting with question 1. Which one of the following could be an accurate list of the colors of the lights that decorate stores 2, 4, 6, 8, and 10 respectively? First, use your clues and deductions to eliminate any choices that you can. Also, if any of the answers matches an arrangement in your previous work, that would be a correct choice, since it could be true. Choice A breaks rule 3, since it includes no yellow. Choice B looks okay. You haven't done that sequence yet, so leave it in. Choice C conflicts with your deduction that store 6 must be green, so it's out. Choice D violates clue 4 by putting green instead of red into slot 4, so eliminate it. Choice E has 2 yellows, which violates clue 3. Cross off E, and you're left with B as the correct answer. On to question 3, the second general question. It asks, which of the following statements must be true? Since you have a lot of deductions, the first step is to see if any of them show up in the answer choices. And there it is, in choice B. You already deduced that red lights always decorate store 1. Circle B, and you're done with the question. Finally, let's work question 5, the complex question that changes the original conditions. The question asks, suppose that yellow lights decorate exactly 2 stores, not just 1, on the south side of the street, and decorate exactly 1 store on the north side. If all of the other conditions remain the same, then which of the following statements must be true? First, you need to symbolize the new information and cross off the rule that it replaces. Next, make new deductions, making sure to check if your existing deductions still apply. Nothing has changed on the north side. However, now that you need 2 yellows on the south side, one of them has to go in slot 2 to keep them from being next to each other in 8 and 10. Since you have just made a deduction and the question asks what must be true, take a look at the choices to see if one of them assigns yellow to store 2. And there it is in choice D, which is your correct answer. Overall, spatial games require you to focus attention on shapes and block clues, which helps you to sort the elements into the diagram. Don't be afraid of spatial games. They may seem a bit weird right now, but they can be some of the most fun games on the LSAT.